Hello everyone, my name is Nizal Ahmed and I will be talking about the work that we done in our project investigating multimodal knowledge graphs as infrastructure for digital twins of financial operation risks. The project was funded by the UKFin Plus and it was in collaboration with our industrial partner Irami AI, who provided us with insights of what is needed in the financial sector. Today I will be talking on behalf of the team, our primary investigator Dr. Anelia and my colleague Yuting, who is like me, the research assistants. The project ran between September and December 25. The collaboration with the industrial sector provided us with the knowledge about the prominent concerns in the field, the standards of interest like the CMD and FIBO. They also helped us with the visualization of the product lifecycle stages and the relevant risks. The project aims to help financial institutes with their financial risk systems to resolve their lack of reasonability over heterogeneous financial data, limiting their capability to respond to emerging vulnerabilities. This was translated as a need for a unified machine-readable representation of critical financial data to make consistent, explainable, or context-aware decisions across products' life cycles. In this project, we aim to investigate the use of multimodal knowledge graphs for modeling financial risks, derive an ontology to support multimodal knowledge graph construction, identify and collect relevant multimodal data on financial operation risks to facilitate the construction of the multimodal graph. Finally, we aim to build and validate a proof of concept multimodal knowledge graph. In order to achieve these objectives, the project was separated into three main milestones: the ontology engineering, the data collection, cleaning analysis, and finally, the multimodal knowledge graph prototype implementation. Ontology development was applied according to the Ontology 101 methodology, one of the well-established methodologies in the field. Investigating the available ontologies, we extended and extracted the required semantics. Modularity of the ontology was guaranteed through the use of separate IRIs for each module to provide flexibility in extending and amending of the ontology. In its final form, the ontology included over 150 classes and over 200 object and data relations, which we used to model the mortgage lifecycle and reason about the associated risks in each stage. The data was obtained and collected from the available online open sources, including the FinMay Foundation. It was then pre-processed to ensure data readiness. Multimodal data was found to be integrable into knowledge graphs in one of two ways, either by direct embedding as vectors using NumPy or utilizing a large language model interface to extract data using automated feature extraction. The second approach was more fitting and suitable for our use. The data was designed to represent three scenarios: good, bad, and average. The knowledge graph operationalization was done through the GraphDB software using the RDF data mapped from the data that we have processed in the previous step using the OntoText Refine software. This enabled us to use SparkQL to query about different risks and their sources through different stages. Here we can see all the risks and their sources across the knowledge graph. We can focus more on specific steps like the application stage, where we've got the application and all of its relevant risk sources. As an outcome, we concluded that multimodal knowledge graphs are indeed a good solution to provide an infrastructure for modeling and querying about financial operation risks. However, the quality of this model and its capabilities are highly associated with a set of things, including the extent of the ontology that is used, the completeness and accuracy of the data that is used to populate the ontology and the knowledge graph, the quality of the RDF mapping that has been applied. Based on these takeaways, we recommend that institutes use locally developed data to ensure the proper coverage of all products and their life cycles. Also, extending used ontologies with tailored modules to reason about their life cycles. Finally, while automated means for data extraction and mapping are required for accessibility, The first data mapping should be done under expert observation to ensure accuracy and complete coverage. Future work includes the employment of prediction algorithms such as LSTM and XGBoost to enable risk prediction based on extracted patterns from data. This would enable the deployment of a multimodal knowledge graph-based digital twin capable of modeling financial risks. Finally, we would like to thank UKFin Plus for their support during this project and our industrial collaborator who helped us to get a better understanding of the field. We hope to see you soon in more and more exciting projects. Thank you very much and see you.